Welcome to this video about bond angles in organic chemistry. To begin, if we know the hybridization of the central atom, then we'll know the bond angle it creates. If the central atom is sp hybridized, the bond angle will be 180. If it is sp2, it will be 120. And if it's sp3, it will be 109.5 with some special situations that we'll go over the video. So let's begin. Okay, so let's begin with finding the hybridization of the central atom to find the bond angle. If the central atom, like carbon in methane, is connected to 4 groups, it will be sp3 hybridized. To find the hybridization, we just count the groups. So the first group is H to C, so S. Next one SP, sp2, and sp3. So there's 4 groups, so it would be sp3, and that corresponds to 109.5 for the bond angle. If we try boron, and boron is connected to 3 groups, we just count the groups, so it would be S, sp, and sp2, and that would be 120 degrees for the bond angle. Next, ammonium, no, just ammonia, not ammonium. Nitrogen is connected to 3 hydrogens, and it has 1 lone pair on top. So let's count the groups: S, sp, sp2, and sp3. The lone pair on top is considered a group as well. So it would be sp3, and the bond angle would be less than 109.5, and it's less than 109.5 because of the lone pair. The lone pair creates electron repulsion, causing the bond angles to be smaller. This is more closely related to the bond angle of 107.3, and different textbooks give different numbers for the bond angle, but it's an approximation, so 107.3 is pretty close. For the next one, we have water, H2O. So oxygen is connected to 2 hydrogens, and it has 2 lone pairs. So let's count the groups: S, sp, sp2, and sp3. Again, it's sp3, so it would be 109.5, but the 2 lone pairs make the bond angle smaller. And it would be smaller than 107.3 because of the extra lone pair, and the approximate bond angle is 104.5 for H2O because of the lone pairs, which cause electron repulsion. Okay, so now I want you to find the bond angle in green. I want you to pause this video and come back and unpause it when you're done. Okay, so now let's begin. To find the bond angle, we need to find the hybridization of central atom. So this would be S, sp1, sp2, and sp3. The bond angle normally for sp3 would be 109.5, but in this case it would be less than 109.5. It'd be closer to 107.3, and I would talk to your professor and ask whether she wants a more accurate bond angle. For the next one, it would be S, sp1, and sp2. It wouldn't be sp3 even if there's 1 electron, because there has to be 2 electrons. Without the 2 electrons, it is not a group. So it's only sp2, and sp2 corresponds to 120 degrees. For the next one, the bond angle is determined by the hybridization, so S, sp, sp2, so 120 degrees also. For the boron connected to 4 groups, that would be sp3, and that would be 109.5. The bottom left, carbon is connected to 1 group and a second group, so sp, and sp is 180 degrees. For nitrogen here, it has 4 groups, so it would also be sp3, and that is 109.5. For the final one, the hydronium ion, oxygen has 1 group, 2 groups, 3, and 4. So sp3 would be 109.5, but it has 1 lone pair on top, so it'd be less than 109.5. And maybe closer to 107.3, like the ammonium ion NH3. Thank you for watching this video. If you have any suggestions on how to improve this YouTube channel, please let me know in the comments, and thank you for your time. Goodbye.